Hello students, once again welcome you to GK's maths classes. Today in this video, this is a concluding video on functions and relations. In this video we are just going to do a couple of more questions in one-to-one and on-to, and then I'm going to talk about the number of reflexive, symmetric, transitive relation, number of equivalence relation, and also the number of bijective functions. Okay, so let us go into the problems. First of all, as we know, this is the definition of one-to-one function. I don't want to write again, so I've written it already. A function is one-to-one if it satisfies these conditions. So I'll go straight into the problem. I will also put the link of all the videos pertaining to functions and relations in this in the description box for your reference. Okay. Now, consider the function f from 0, pi by 2 to r given by f of x is equal to sin x and g of x is cos x. Now show that if f and g are one-to-one, f plus g is not one-to-one. Okay, so it's clearly given that f and g, it's given that f of x equal to sin x, and this is one-to-one, and g of x is equal to cos x. This is also one-to-one. These are NCERT worked out example problems. Okay, now what is f plus g of x? F plus g of x is nothing but f of x plus g of x from the properties of functions. Now what is f of x? F of x is sin x and g of x is cos x. F plus g of x. Now I want to check whether it is one-to-one or not. Okay, so what I will do, I will take f plus g of 0, which is sin 0 plus cos 0. Sin 0 is 0, cos 0 is 1, therefore it's 1. Now I will find f plus g of pi by 2. This is sin pi by 2 plus cos pi by 2. Sin pi by 2 is 1, cos pi by 2 is 0. So clearly 0 not equal to pi by 2. F plus g of 0 equal to f plus g of pi by 2. This implies f plus g is not one-to-one. F plus g is not one-to-one. Okay, but clearly f and g are one-to-one from the graph. But if you want, we can show it. Let us take f of x equal to sin x. For every x1 comma x2 belongs to 0 comma pi by 2. 0 comma pi by 2 means sin x is an increasing curve, 0 to pi by 2, and clearly it's one-to-one, but we'll just verify it. F of x1 equal to f of x2, and therefore sin x1 equal to sin x2. So no values are repeated, so x1 equal to x2. This implies f is one-to-one. Similarly, you can do for g of x. G of x is cos x. Now cos x graph is going to be like this, exactly like this. It's definitely one-to-one. For every x1 comma x2 belongs to 0 to pi by 2, g of x1 equal to g of x2 implies cos x1 equal to cos x2. So in 0 to pi by 2, clearly x1 will be equal to x2. This implies g is one-to-one. So what have we proved? If f and g are one-to-one, you proved that f plus g is not one-to-one. So it was not a property like if f and g are one-to-one, f plus g should be one-to-one. No. If f and g are one-to-one, here is an case where f plus g is not one-to-one. Now this is our last problem in this. In is an identity function. What is an identity function? It returns the same value. Identity functions are like x goes to itself. For example, if I have 1, 2, 3, in will take 1 to 1, it will take 2 to 2, it will take 3 to 3, and it will take n to n. This is the definition of in of x. In of x. Okay. Now you have in plus in. This is a new function. This is a function from n to n. Now how it is defined as in plus in of x is nothing but in of x plus in of x, just like what we did in the previous problem. But you know in of x is nothing but x, so it is equal to 2x. So in plus in of x equal to 2x. Okay, so 2x is an even number. So odd numbers, odd natural numbers under the function in plus in will not have pre-image. That is, for example, if you take 1, 2, 3, 4, 5 and so on, this is the function in plus in. How it is defined as? It is defined as 2x. So 1 will go to 2, 2 will go to 4, 3 will go to 6, 4 will go to 8, like that. But all the odd numbers 1, 3, 5, 7, they do not have a pre-image. Therefore codomain, so what is the range? Range is even natural numbers, which is not equal to the codomain. Therefore in plus in is not onto. It's a very, very simple problem. It's a worked out example question in the NCERT book. Okay. Now I want to explain some concept first before we go to the problem. Now the first formula, which this is all pertaining to 1 mark question. Okay. Suppose f is a function from a to b. Suppose f is a function from a to b. Okay, where the number of element in a, the number of element in a, I call it as m, and the number of element in b is n. Okay, then what is the number of element in a cross b? The number of element in a cross b will be m into n. Right? Now the number of relations f from a to b. I am talking about relations, number of relations f from a to b. It is a subset of a cross b. So how many subsets are there? 2 to the power of m cross n, right? So the number of relations f from a to b will be 2 power mn, will be 2 power mn. Okay. Now what will be the number of relations f from a to b which are functions? So you know every function is a relation. So what is the number of relation f from a to b which are functions? So this is basically what is the number of functions f from a to b. In fact, I'll reword it as number of functions f from a to b. The formula is number of element in the codomain whole raised to the power of number of element in the domain. I want you to remember like this. Okay, which is nothing but, here how many elements are there in the codomain? Codomain have n elements. How many elements are there in the domain? N. So it is n power m. Okay. Now what is the number of relations f from a to b which are not functions? Which are not functions. This is the total number of relation, which includes relation as well as function. These are the number of only functions. So what is the only relation which are not functions? It will be the total relation minus the number of functions. Okay. So these formulas are very, very important. Make a note of it. It will help you to solve 1 mark questions. Okay. Now if I fine tune this, okay, suppose f is a function from a to a. F is a function from a to a. So what will be the number of elements in a cross a? Number of elements in a cross a will be n square. Correct? Number of elements, it will be m square. Here it is m, so I call it m square. So what will be the number of relation? Number of relation will be 2 to the power of m square. Here the number of elements in A is taken as m. What will be the number of functions? Number of functions will be m power m. It is m power m. What will be the number of relations? Number of relations which are not functions. It will be 2 power m square minus m power m. Same, if it is two different sets, this is the formula. If it is on the same set, this is the formula. So please make a note of these formulas. Once you know the formula, based on the question, you can always put the values and get it. Okay. Now we have to talk about number of one-to-one onto functions. Okay. Let us assume that f is a function from a to b. Okay. And number of element in A is m and number of element in B is n. Okay. Number of element in A is m, number of element in B is n. Suppose m is less than or equal to n. First let's talk about less than. If m is less than n. So what will be the number of one-to-one functions? The number of one-to-one function will be npm. It is nothing but npm, permutations, npm. Now why? It's very, very simple. Suppose if you have 1, 2, 3 and if this has 1, 2, 3, 4. Now how many one-to-one functions are there? So here you can see clearly number of elements in A is 3, number of elements in B is 4. Clearly m is less than n. Okay. Now this 1 can go to any of these 4 elements. So this 1, there are 4 ways it can go. 1 can go to any one of the 4 elements. So let us assume 1 has gone to 4. Okay. Now 2 can go to any one of the 3 elements. So they have 3 ways of doing it. So 3. So let us assume 2 goes to 1. Now 3 can go to any 2 elements. So there are 2 ways. So what is 4, 3, 2? It is nothing but 4, P, 3. That is exactly what I wrote here. Correct? So what will be the number of onto function? Onto function means no element should be left out. Okay. So here 2 is left out. It can't be onto. If you want to map 2, either I should connect 1 to 2 or 3, 2 to 2 or 3 to 2. If I do that, it will not be a function. Suppose if I connect 1 with 2, 1 is already connected with 4, so it can't be a function. So the number of onto function is not possible in this situation. So the number of onto function is 0. When m is less than n. When the number of element in the domain is less than the number of element in the codomain. Now what will be the number of bijective function? the number of bijective function will be obviously 0 because it is 1 to 1, but it is not possible to have onto. Since it is not possible to have onto, the number of bijective functions will be 0. So very, very important. So make a note of this. This will be very useful for you. Okay. Now let's go to the next one. F is a function from A to B where the number of elements in A is m and number of elements in B is n, and clearly here m is greater than n. Clearly m is greater than n. For example, if I have 1, 2, 3, 4, and if I have 1, 2, 3, what will be the number of one-to-one function? So let us say that's it, it's finished. If I join 4 with 3 or join with 4 with 2 or join 4 with 1, it will not be one-to-one. So it is impossible to have a one-to-one function here. So what will be the number of one-to-one function? Number of one-to-one function, one-to-one function will be 0. The number of one-to-one function will be 0. So what will be the number of onto function? Number of onto function, it's difficult to do, but there is a formula. I'll give you the formula. Okay, in case they ask, they may not ask you. In case they ask, you can use it. You can say R equal to 1 to n, 1 to n, minus 1 to the power of n minus r, n c r, r power m. Okay. If you put it in this, you will get the number of onto function. But to my knowledge, this is not required. Just for information, I gave you. So the number of one-to-one function is 0. The number of onto function can be calculated using this. So what will be the number of bijective function? The number of bijective function will be definitely 0. The number of bijective functions will be 0. Now, third case. This is case 1. This is case 2. Now, what is case 3? F is a function from A to B where the number of elements in A is m and number of elements in B is n, and both are equal. If the number of elements in A and B are equal. So let us take a simple example. 1, 2, 3, 1, 2, 3. Okay. So 1 can go to any one of the 3 elements. So there are 3 ways. Let us assume it goes to 2. 2 go to any one of the other 2 elements. Otherwise it can't be 1 to 1. So there are 2 ways. Now 3 have to go to 3. So there's only one way. So this is basically 3 factorial. Okay. Therefore, the number of one-to-one function is, in this case, either it is n factorial or you can call it m factorial because n equal to m. What is the number of onto function? If the numbers are same, okay, and you can see clearly if the elements are same, it has to be n factorial. All one-to-one functions are onto. That is what we did in the previous problem. In the previous video, we have a question like if number of elements in A and number of elements in B are equal, if the function is one-to-one, it has to be onto. If the function is onto, it has to be one-to-one. Again, I repeat, if the number of element in A and number of element in B, and f is a function from A to B, if it is one-to-one, it has to be onto. If it is onto, then it has to be one-to-one. Therefore, it's very clear that if you have n factorial one-to-one function, there must be n factorial onto function. So what will be the number of bijective functions? Number of bijective functions will be n factorial. So don't forget these formulas. If you know these formulas, you can attempt any one mark question pertaining to, first is pertaining to number of functions. Number of functions, number of relations which are not functions. Number of relations which are not functions. These 3. If it is from A to B or from A to A, you can attempt any question. And here, f is a function from A to B. if the domain have less number than the codomain, what is the number of one-to-one, onto, and bijective? If the number of elements in the domain is more than the codomain, I have it. If they are equal, this is the formula. So with this you can do any problem. Okay. Now last part is I want to find how many reflexive, symmetric, and transitive relations are there. Okay. So let us take, for example, a set A which have n elements. Okay. So R be a relation on A. If R is a relation on A, then R will be a subset of A cross A, correct? So what is A cross A? A is having A1, A2 up to An. Okay. So let me write that A1, A2, A3, A4 up to An, and here you have A1, A2, A3, A4 up to An. Okay, I need some space, so A2, A3 up to An. So what will be A cross A? A cross A will be A1, 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 A2, A1, A3, A1, An. Okay. What about the next one? A2, A1, A2, 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 A3, A2, An. This will be A3, A1, A3, A2, A3, A3. This is A3, An. If you continue like this, you get An, A1, An, A1, An, A2, An, A3, and finally it will be An, An. So there will be totally n cross n elements. Okay. Now, how many diagonal elements are there? So these are the diagonal elements. Okay. Look at this. There are totally how many diagonal elements are there? So the number of diagonal elements are n. There are totally n diagonal elements. Okay. What will be the number of non-diagonal elements? Number of non-diagonal elements are, what's the total number of elements? Total number of elements is n square. In that I remove the diagonal elements. So it is n square minus n. Number of reflexive, I am talking about number of reflexive relation. In number of reflexive relation, definitely the diagonal elements must be there, correct? Definitely all the diagonal elements must be there. There's only one way. A11, A22, A33, ANN must be there. So diagonals must be there. Diagonal is compulsory. And how many ways you can select all the diagonals? Only one way, correct? You have to select all the diagonals, okay? Diagonal elements can be selected in one way. For a reflexive relation, definitely all the elements in the diagonal should be there, which can be done in one way. That is very clear. Now, along with the diagonal, the non-diagonal elements may exist or may not exist. Okay? So that means the non-diagonal elements have two options. It can exist or it need not exist. So there are two ways. So non-diagonal elements may exist or may not exist, may not appear. Okay, it may appear or may not appear for a reflexive relation. You know, A11, A22, A33, ANN should be there, but whether A21 or A31 is present or not, it doesn't matter for a reflexive relation, because if it's there or not there, it will be reflexive. So each element have two ways. So how many non-diagonal elements are there? There are n square minus n non-diagonal elements. Each diagonal element have two options, right? It may appear or may not appear. So therefore, the number of reflexive relation will be 1, that is diagonal element should appear, that is 1, and non-diagonal element should not appear. What is non-diagonal element should not appear? How many non-diagonal elements are there? N square minus n. Each have two options. It can appear or need not appear. Therefore, it is 2 to the power of n square minus n. So the number of reflexive relation will be 2 power n square minus n. Very nice problem. You see, the number of reflexive relation will be 2 power n square minus n. How did I come up with this number? The number of ways you can select all the elements in the diagonal is only one way, and the non-diagonal elements, how many elements are there? N square minus n, and each of them may appear or may not appear. So there are two options. Therefore, it is 2 power n square minus n. Number of symmetric relations. For a symmetric relation, the diagonal elements may be present or may not be present. The diagonal elements may or may not present, may not appear. It doesn't matter. If A11 is A1 is not there, it doesn't matter. It can be symmetric. If it is there also, it's fine. So there are two options. Okay, there are two options. But how many diagonal elements are there? There are n diagonal elements. So each element will have two options. So there are 2 power n. So the number of diagonal elements may appear is 2 power n. Okay, 2 power n. Now look at the non-diagonal elements. If A21 appears, A12 will appear. Okay. So if A21 appears, it's understood that A12 will be there. If if A3A1 appears, it's understood that A13 will appear. So it is not necessary for me to talk about the entire non-diagonal element. It is enough for me to talk about only the one half of the non-diagonal elements. So how many non-diagonal elements are there? N square minus n. How many, what is half of it? That is n square minus n by 2. Okay. It may appear or may not appear. It's again I have a choice. It can be there or it need not be there. If it is there, it's 1. If it is not there, there are two ways. Therefore, it is 2 power n square minus n. So the number of diagonal element may appear or may not appear. See, this diagonal elements may appear or may not appear. So they are, each one have two options. Each one have two options. So it is 2 power n. Okay. Now if this may appear or may not appear, this may appear or may not appear, this element may appear or may not appear, this element can appear or need not appear. How many such elements are there? There are totally n square minus n by 2, because the total non-diagonal elements are n square minus n. Half of it will be n square minus n by 2. Since it can appear or not appear, each element have two options. Therefore, it is 2 power n square minus n by 2. So the number of symmetric relation will be diagonal may or may not appear, and means multiplication, 2 power n square minus n by 2. So if I simplify this, I get 2 power n plus n square minus n by 2, which is 2 power n square plus n by 2. This is a wonderful formula. Number of symmetric relation is given by this. This is the number of symmetric relation. Now, we have to go to the transitive relation. Okay. Well, to be honest, there is no formula for finding number of transitive relation. You can refer to the net. There are some proofs that is given, but it is beyond the scope for us, so we will not go into that. So we are not going to talk about number of transitive relation. Now finally what we are going to do, we are going to talk about number of equivalence relation. The number of equivalence relation. The number of equivalence relation is what? Is nothing but the partition set, right? What is it? What is the equivalence relation? Partitions the set. Equivalence relation. What does it do? Partitions. Partitions the set into equivalence class, right? This is what we have done this in the beginning. It divides it into disjoint subsets. Okay. So what will be the number of equivalence relation? It is actually once again given by a formula called Bell formula. You can refer more in the net. I don't want to go into that. It's complicated for our level, so we will not go too much into it. But it is given by this formula. The Bell number. It's called the Bell number. Okay. So B naught is 1. It is defined as 1. B1 is also 1. B2 is 2. And B3 is 5. Okay. And you have a recurrence formula. Bn plus 1 is given by sigma k equal to 0 to n nck bn. If you put it in this, you will get it. Okay. I'll just give you a small quick representation of this. Suppose if my set A have 2 elements. So let us see how many equivalence relations are there. So first relation is, you can have 1, 1, 2, 2, correct? 1, 1 and 2, 2, which is an equivalence relation. So if it has 2 elements, right? 1, 1 and 2, 2. What's the next one? It can be 1, 1, 2, 2, 1, 2, 2, 1. See how many equivalence relations are there? Only 2. That is what we got here. B2 is 2. Can you see it? So B2 is 2. Let us take A equal to 3 sets, 3 elements. So what are they? R1 is 1, 1, 2, 2, 3, 3. Then R2 is 1, 1, 2, 2, 3, 3, 1, 2, 2, 1. R3 will be 1, 1, 2, 2, 3, 3, 1, 3, 3, 1. Or it can be R4, which is 1, 1, 2, 2, 3, 3, 2, 3 and 3, 2. Or you can have R5, which is A cross A. Okay. So 1, 2, 3, 4, 5. That's exactly what I got here. If an element have 3 elements, there will be 5. If it has 4 elements, use it in the formula. There is no way the CBSE is going to ask you questions on how many equivalence relations are there with 4. They may ask you for 3. Okay, that you can note down. It's 5. They may not ask you for 4, 5 or 6 because it is beyond the scope of your NCERT book. But it can be got using this number called the Bell number. The details of Bell number, you can always refer to the net and understand what it is. Okay. So these formulas are very, very useful. I hope you understand this, especially the number of reflexive relation. The number of reflexive relation will be 2 power n square minus n. If you understand the derivation, good. Otherwise, by heart the formula. Number of symmetric relations 2 power n square plus n by 2. You cannot have a formula for transitive, so I did not do it. And the number of equivalence relation is given by this. Okay. If you still have a doubt, you please message me in your comment section. With that, we are going to complete this entire chapter on relations and functions. I hope this video was very useful to you. Thank you very much. Please subscribe to my channel and click the bell icon to get notifications of all video. See you again in the next class. Have a lovely day. Bye bye.